What's up guys, this is Nefarious Intent back for part 4 of the Minecraft 1.8 hack client coding tutorial. Today I'm going to be teaching you how to code a TabGUI as well as a few other hacks. Let's open our Eclipse and get right into it. This video is brought to you by Intent.store, the leading marketplace for premium Minecraft hack clients. The first thing I want to do is go back to the code we've made over the previous tutorials and sort of optimize it a little bit and bring it into the modern Java meta. So one of the things we want to do is change the project from Java 1.6 to Java 1.8, and you could do that by right-clicking your client, going to the build path, configure build path, scrolling to the bottom, and then where it says Java System Library, you click on that, and you want to change the execution environment to Java SE 1.8, and then finish and apply and close. That'll allow us to use lambdas and other modern Java concepts that can allow us to just code faster and do more things in less code and that sort of thing. The other thing I want to do is change our package representation so it's a bit more optimized. So you click this little down arrow, you go to package representation and you choose hierarchical. Now it doesn't take up our whole screen and we can only see what we want to see, and it's nice. So now that our project is Java 1.8, it means we can do stuff like this. We can sort the modules using less code than this whole subclass we just created. So you can just open up some space right here, type client modules, and then we're going to say sort, similar to the old one. And then we're going to type comparator. And then now you're going to see more options than you would have if you were still on Java 1.6. And we're going to choose comparing int, I believe. Maybe we'll choose comparing double or something, I don't know. But we're going to start with the integer comparison. M for module to create a little local variable in the context of this. And then we're going to cast it to module because it's just a generic object right now. And then we can find the name. And later we're going to use a display name when we have suffixes and stuff. But we're going to choose the MC font renderer object, get string width. And that. And make sure you have enough parentheses. Okay, so if we boot up Minecraft, it's going to sort it either lengthwise up or lengthwise down, and we're going to have to act accordingly to what it chooses. Also, we can comment out this existing comparator line and we can erase all this stuff as long as it works. So if I turn on sprint and fly, you can see it's actually sorting the wrong direction. So at the end of this, we can just type reversed, and then because it's a lambda, we have to actually recompile, so there we go. And now if I enable sprint and fly, you can see it's sorted the right direction. So we can actually get rid of all this and this line. So now we've optimized the sorting algorithm. So the next thing we want to do is optimize the GL stuff, all the translations and scales and everything. So we can actually do this in less lines just by typing GL state manager push matrix. So in OpenGL, there's a concept called pushing and popping. This isn't something unique to OpenGL, but in this instance, you can push and it'll sort of create another layer of depth to what you're drawing, and you can pop it and it'll end anything, for the most part, that you've done in that little layer. So at the end of it, you want to pop. So you can see that the tutorial text is at the 2x scale and everything else is at the 1x scale, and we're now using less lines of code. So we've optimized our scaling and translation method for the logo. You can also hide your imports by clicking this, so it'll just make your class look smaller. And if you want to, you can add indentation to your lambda to make it more clear that there's like a subroutine going on inside. Also, if you're following along in this tutorial with 1.8.8 instead of the 1.8 we're using, you're going to have an error when you try to create a scaled resolution instance. So if you're using 1.8.8, you're going to want to get rid of all this stuff. And for me, it's not going to work, but for you, if you save it here, it should get rid of any errors you're having. This is just like an edge case that some people watching the tutorial experience. I'm going to undo it for my case. So the first thing I want to do before we get into coding the new hacks is to revise the old hacks and make them more efficient. And then I also want to do this one thing right here, changing the font renderer object to the local variable one. So I'm going to start in fly. You can see this code, there's a lot of code here and it's kind of unnecessary, and it would break creative mode if you tried using it a little bit. And it also, if you landed on the ground, you'd have to re-enable fly. So I'm going to change this. I'm going to remove the onEnable method because we don't actually need that. We also don't need the allow flying capability. We just need to make sure we set allow flying as false when you turn it off. And then over here in the event update, we're going to set it to true every tick. So if we start the client, we'll see the difference. As you can see, when I turn it on, I'm flying. If I turn it off, I stop flying. If I land on the ground, come back, go up, come back, I'm still flying until I turn it off. And if we're in creative mode and I turn on their version of flying and then I turn this on, it's the same. And if I turn it off and then try flying with creative mode, it still works. The other thing I want to do is make the sprint bypass more anti-cheats, because, believe it or not, you can get banned for sprint if it's badly coded. So one of these examples is the Omni sprint, where some anti-cheats can pick up that you're sprinting backwards and flag that. So we're going to check to make sure you're only moving forward like a legit player would when they're sprinting, and then turn off sprinting otherwise. So above this little set sprinting method, I'm going to create an if statement. I'm going to call it if Minecraft.theplayer.moveForward is greater than 0, so we know it's not -1 or backwards, it's only forwards. So we can try that. So if I turn it on, it sprints forward and it doesn't sprint backwards. We also want to set the set sprinting state on disable to mc.gamesetting.keybindsprint. Get is key pressed. So that way it'll only disable sprinting if you're not actually holding the key down. So I'm holding the key down now, so I turn it off, I'm still sprinting. And if I'm not holding the key down, I turn it off, I stop sprinting. There's a few other edge cases that you're going to want to handle, or else you'll also be flagged by the anti-cheat. So one of these is you want to make sure you're not using an item. So we type mc.theplayer.isUsingItem, and we make sure it's not. So if I were to give myself a sword, turn on the sprint and block the sword, as you can see, I'm not sprinting, and then I am sprinting, and I'm not sprinting. And then we also want to make sure you're not sneaking. So mc.theplayer is sneaking, and make sure there's an exclamation point in the front so it knows it's not. So if I sneak. Another one is we want to make sure we're not colliding against a wall. So mc.theplayer is collided horizontally, and make sure you put an exclamation point in front of that as well. And then if we walk into a wall, we stop sprinting. And if we stop walking into the wall, we're sprinting again. So for most cases, this will completely bypass all anti-cheats. So the next hack we're going to make is called FullBright. You all know about it. It basically just turns the gamma of the game way up so that nothing's really that dark. So we're going to start by copying the sprint module. But instead of just pasting it in movement, we're going to create a new package, and we're going to call it render, so we can organize our modules by category. So we're going to hit Control V to paste it, and then we can right here right click it and go to refactor, rename, and type in FullBright. I'm going to spell it with the capitalization like that, but you can spell it however you want. And then paste it in there. And then I'm going to change the keybind for it to like O or something I don't really use. So we can get rid of the on event. We can get rid of the sprint statement. And basically what we want to do is put in on enable mc.gamesettings.gamma-setting equals something high like 100. Because I think it's only between 0 and 1, so 100 is way above that. And then on disable, we want to set it back to something like 1. If we wanted to go the extra mile, we could actually store the value of it in game settings before it's enabled. But if you leave this hack on and it saves your game settings stuff, it'll sort of overwrite that, so there's not really a point in doing that. Also, why do you really care if your gamma ever goes below FullBright levels again? You're hacking. So we have to instantiate this module, which is pretty simple. We go to the client class, and we just copy the sprint, and then change it to FullBright. And then add a little capitalization there. And import it. Another little cheat code you can use is by going to the imports and replacing fly and sprint. You can get rid of sprint and just change the fly to a star, and then it'll import all classes in that package, and same with FullBright. So now when you instantiate future modules in those categories, you won't have to import anything. And once all 4 categories have modules, you'll never have to import anything again in the client class when you're instantiating modules. So we can go ahead and debug and see if it worked. If I make it night, I'm gonna turn on FullBright. Big difference right there. If I turn it back off, it goes to a sort of quasi in between where we were before, but you can tell there's a big difference. So that's FullBright, that's sprint, and that's fly. Next, we're going to code a NoFall, which is also super easy, and big thanks to Hypixel for allowing this method to work again on their server. They actually patched it a while back, but recently, for some reason, they rolled back the patch, so it works again. So you're getting top tier stuff here. So we're going to create a new package called player. I also apologize for my typing. I make typos frequently. I'm going to paste in the FullBright code, and then I'm going to do the same thing. Refactor, rename, and call it NoFall. And then paste that there. Oh, we also have to adjust the categories. I made a big mistake here. This isn't a movement hack, this is a render hack. So for NoFall, we don't need any on enable or disable statements. We just need the event statement. So on event E, if E instance of event update, and E is pre, then we want to check if the player fall distance is greater than 2. We want to send some packets. So for this tutorial, I'm going to show you the basic way to code a NoFall, but there are ways you can conserve packets that are a little bit more complex and start to interfere with other hacks, so there's even more steps you have to take to make them work. So for the scope of this tutorial, maybe in the future I'll show you the more complex way, but right now we're going to just send packets as long as your fall distance is greater than 2. We're going to type mc.theplayer.sendQueue, add to sendQueue, new CO3 packet player with the on-ground state set to true. So if we instantiate this in the client class, we import and we change the NoFall to a star and boot it up. Also changing the keybind to M for NoFall. If we change our game mode to survival, we turn on NoFall, we fly up, and then we drop. We didn't take any fall damage. Whereas if I turn it off and we drop, we take a lot of fall damage. So that's NoFall, and it will work on Hypixel. So now we're going to code a TabGUI, and the first thing we have to do before we get started with that, we have to add string names to our categories so that we can access those if the client becomes obfuscated or whatever the situation is, so we're not relying on field names. And we also need to create a get modules by category method in our client so that we can get modules by category. So first let's get started by modifying the categories. So I'm going to go to the module class and scroll to the bottom, and then right after the render, I can actually get rid of that semicolon, I think. I probably have to add it back in as soon as I create fields. So I want to create a public string called name, and then I want to just create, with no modifiers, a constructor called category with the parameter name, and then I want to set this name equal to that name. There's going to be errors over the existing fields because we need to add the proper name to them. So you just put a parenthesis there, your string, and another parenthesis to close it. So we got combat, movement, player, and render. So that part's done. Next, we need to go to the client class and create a new method called public list with the type module called get modules by category. You could also just call it get modules, but I don't want the name contaminated if we do a get modules method as well. So we'll do get modules by category. And then for the parameter, we want category C. Then we're going to import those by hitting Control-Shift-O, choosing our own category class, and choosing the util list. So there's going to be an error because there's nothing here to return. So we're going to create a new list with the same type called modules equals new array list module. We're going to import array list as well. Then we're going to type for module m out of this modules, so the global version, and we're going to say if m category equals the category above, then we want to add that to the module's local variable. So modules add m, and there we go. You can tell it's a local variable because it's colored brown, whereas the global one's colored blue. So at the end of the method, we want to say return modules, and there we go. So now we want to create a new render module called TabGUI, and we can copy the FullBright, paste it, and call it TabGUI. Go to it, put in the proper name, and in this case we don't really need a keybind. We could just set that to none for now, but we can set the toggled state to true in the constructor, so it'll always be on. Then we can get rid of the on enable and disable methods and create a new on event method. public void on event. So there's no current event for drawing something to the GUI. So we're going to go into our HUD, and after the logo at the end, we're going to create a new event. So copy the event update from here, paste it into listeners, and you can just save that for now. Call it event render GUI. And then we're just going to paste that. So I'm going to type client.onEvent, new event render GUI, and then close it and import it. And that's all we have to do for that. Now we can come back here and say if e instance of event render GUI. And now this allows us to draw stuff to the screen. We also need to go into the client and register the TabGUI as a module. And because we did the Control-Shift-O earlier, it removed the asterisks importing. So we need to adjust that back. And probably not a good idea to do Control-Shift-O in classes where it uses asterisk importing. We can minimize that. Now we're here, our TabGUI is ready to render, and we can start actually drawing stuff. So I'm going to boot up the client, and we can get started. So when we get into the game, we can see that TabGUI is already on the array list without us even having to enable it, and that means it's running in the background. Now for most of you, you may want to hide this from the array list since it's always going to be there. So you can do this by going back to HUD, and then where it says if module is not toggled, we can also say or, so two pipes, m.name equals TabGUI. And now if we save it, it disappears from the array list. So going back to our TabGUI, we can say GUI.drawRect and give it a starting X, so the left coordinate as 5, so 5 pixels out, 5 pixels from the top, 100 pixels to the right, and 100 pixels to the bottom. And then we'll put in the color as 0x90 00000. So that's going to give us close to 50% opacity. We save it, and what do we get? A rectangle. So we need to move the rectangle by adjusting the Y coordinates. So 15, not quite, 25, 35. Okay, that's all right. We can move it a little bit more snug. So 30. And it doesn't need to be that far out, so we can do something like 80. And the height is going to need to be adjusted later depending on how many categories we have. So we'll start enumerating our categories by typing for category C out of module.category.values, and then we can draw a string for that. We'll bring in a local font renderer variable called font renderer fr equals mc.fontRenderer object, and we'll import it, and we'll say font renderer draw a string with shadow, sure we'll do with shadow, c.name, so that'll be our proper name for the categories, and we're going to choose for our x value something around 8 or 10, and then for our starting value something like 40, and white, which is -1. And what we'll get is this overlapping mess. So we need to create a local variable at the beginning of the enumeration called count, similar to what we did for the array list, and we're going to add to it the end of each enumeration, and then we're going to use it as a factor in the y-axis. So if we save, now they're drawn far apart. If I increase the multiplier, they're farther apart. So I'm going to choose something in the middle like 16, and then I'm going to move the whole object a little bit up to about 36. And there you can see that looks all right. But we can also, instead of using 100 as just a solid concrete height, we can change it to 30 plus module.category.values length times say 16, and what will happen? We'll get something like that that's dynamically drawn. If there were less categories, it would be shorter. And then we'll add a little bit extra to the end, like 2, maybe 4, and that's what we get. And then for the width, there's a couple ways you can calculate that. You could just say, I'll make it longer than any category name would ever be and change it accordingly, or you can make it auto detect using the longest string. For this tutorial, we're just going to do a long rectangle and make sure it's long enough for the existing categories, and we can adjust it later. So our TabGUI is pretty small because there's not a lot of categories, but if you added more to the module class, it'd get longer dynamic. Now, in order to handle key presses, we have to create another event called event key, and we can get started by copying the event render GUI, pasting it and calling it event key, and then inside of it you want to create a new integer, so public int key or public int code if you like, and then we can create a new constructor called event key with the parameter integer code, where this code equals code, and save. We can also, if we optionally want to, create getters and sitters with Eclipse's auto-generate feature. So there we go. Now if we go back into the client class where it says key press, we can just create client on event, new event key, and then plug in that key parameter to it and import it. And then Control S to save, if I haven't already told you how to do that. Control S. Now if we go back to our TabGUI, we can create a new if statement called e instance of event key. Because all events are being passed through this one method, we have to specify which event we're looking for in each block. So now we're accepting key presses, but we need to actually access them. So we're going to create a new object called event key. Or actually, we could just do int code equals event key, which will be our cast, plug in the e variable, and then we're going to type .code at the end and close it up. And now this will be the key code for whatever key is pressed right here, so we can access that later. We also need to create a variable for the current tab we're using. So we're going to call it public int current tab, and that will keep track of what tab we're using. So we need to make our current tab increase when the downward arrow is pressed, and we need to make it decrease when the upward arrow is pressed, and we want to make it loop around if you keep going. We create an if statement called if code equals keyboard dot key, and then you have to use an underscore, key up. Then you want to make the current tab subtract. If the code equals keyboard key down, then you want to make the current tab increase, and we want to say if the current tab is greater than or equal to module.category.values.length -1, then we want to set the current tab equal to 0. Otherwise, up the current tab. And then inversely for the key up, we say if the current tab is less than or equal to 0, then we want to set the current tab equal to module category values length -1, because the length is always 1 greater than the ending index, because indexes start at 0. And then we're going to add our else statement there and indent. Now if we boot up our Minecraft, we can start handling the different tab states. So there's our TabGUI, and we want to draw a little pointer rectangle to show us which category we're hovering over. So right here, after the first background, we can say draw rect, and we're going to say about 6 pixels, and these are actually double pixels, so 12 real computer pixels deep, and then 34, really 33, because we want it to be around centered where the text is, plus current tab times 16, and then you want to make the right of it about 8, and then the bottom will be that plus say 10, and then the color can be whatever color we want. I might use the same blue from earlier in the array list right here. Paste that in and see what happens. So there we go. Combat is selected. If I press the down arrow, movement, player, render. Again, we're back at combat. I can keep cycling through, and I can go the other direction with the up arrow as well. So you can see that's working so far. And I can make it a little bit more flush with everything and make it look better by changing the 10 to something like a 12. Now it looks more centered, and then maybe moving it from a 6 to a 7 and an 8 to a 9. Or maybe turning it from a 9 to an 8. That's thin. Maybe 6.5. Float. Actually, if this is double, we don't need to use float. So just 6.5. That looks okay, but I think it would be better if it was thicker. So I'm going to turn this to a 7, turn this back to a 9, and then I'm going to offset the text from 10 to 11. And this is what we get. I'm also noticing that the top is not quite even with the side offset, and the bottom is also even worse. So I'm going to go back up and I'm going to fine tune it. So instead of starting at 30, maybe we'll start at 30.5 and see how that looks. That looks about right. And then for the bottom, instead of 4, we're going to do maybe 2. Maybe 1.5. That looks about right. We could also make it a full-length rectangle instead of just a little nubbin right there. So the background rectangle is actually 65 pixels wide. So instead of doing 7 and 9, we can do 7 plus 65, and that'll actually exceed the length because that's the full length. So we want to subtract about 2. We'll try that. Okay, and then 2 more. So there we go. And that doesn't quite fit on the text, and we can adjust the text by subtracting from here, or just reducing 36 to something lower like 34. We save it, and it's too high, so we want to do 35 and a half. I think we'll do 35. So there you can see the beginnings of our TabGUI is coming together. So now in order to handle expanding the TabGUI and actually rendering the modules available for each category, we need to create another integer called module index and a boolean called expanded. Now we can boot up Minecraft and get started. So now that we're handling expanding and closing, we need to handle the key left and key right events as well. So I'm going to copy this statement here, paste it, and change this to key right, and erase this inner body and change it to expanded equals true. And we're going to create another one called key left and expanded equals false. Next, we're going to copy our background and selector code. We could actually copy all of this and paste it directly after, but we're going to adjust it a little bit because we're going to change the starting point from 5 to the actual end of the previous version, and then we're going to change 70 to a 72, and we can add 70 to this. We also need to add 70 to the end of that, and I can erase the integer declaration because we can reuse the same count variable for a different purpose. So if I save this, I actually want to add 70 to the text as well. So if I save it, you can see it's now duplicated. It's drawing everything twice, but one's moved over to the side. So we can actually even out the little gap here and make it uniform with the rest of the body of the TabGUI. So instead of 70, we're going to change it to 68. 68. We're going to leave that at 70, and we're going to change this to 70 and see what happens. There we go. It's looking more flush, and we also need to change this a bit. The text is still really far to the right, so we're going to change that to about 60 and see what happens. That's a little bit too far to the left, actually. 62, how's that? So how about we drop the addition and change this statement to 3 above whatever the bottom rectangle is being drawn at, so 73. Save, and there we go. It's now matching, it's uniform, all the offsets are equal to each other, so it looks OCD friendly. And now we can change this enumeration from categories to actual modules in the categories. So I'm going to change this from category to module, change the C to an M, and change this to client dot. And one more thing, we need to go back to the client and change the get modules by category to static so we can access it everywhere. And we can't use this anymore because it's static, so we're going to use client instead, and save. Now if we go back to our TabGUI, we can say get modules by category, plug in the current category by typing module category values, and then using the brackets operator to get an object from inside an array, and we're going to use the current tab index to pull that. And then we're going to change the C to an M as well, and let's see what happens. We're also going to want to change the current tab to module index over here. And we can simplify what we're doing by creating a new local variable list called list modules, modules equals that whole statement. Import the list from util, and then use modules.size instead. And over here we can plug it in as well. And we can boot up our Minecraft. And what do you know? There's no combat modules yet, so that looks weird. There are 2 modules in movement, and there's 2 modules in render and 1 in player, so you can see it's starting to look like a TabGUI. So now we want to say we only draw this if expanded is true. And then indent there. You can actually highlight a block of code and then press tab and it'll indent the whole thing. Inversely, you can highlight the same block and hit shift tab to unindent it. So now it only draws the combat tab if we press the right arrow and hides it if we press the left arrow. Same with movement, same with player render and all the other categories. We also want to make a blanket statement and say if modules.size equals 0, then we want to return. Now this won't work if we're drawing stuff or processing other things after this event, but since we aren't, there's no issue with doing this. So as you can see, nothing happens when I press any of the keys for combat, but it does work when I use module, player, or render. So you'll notice one thing. If we press the up arrow while something's expanded, it just goes to the next category instead of going to the next module, because we need to implement the expanded variable into the rest of the key events. So we can say for key up, we only want to move the tabs if expanded is false. So if not expanded, or if expanded, we do something, and then otherwise, so else we do that. And we can copy this for the key down event as well and indent it properly. So now, if I press the up or down arrow, nothing happens until I exit. But it's still not toggling the modules when I hit the right arrow again because we haven't implemented that yet. So now we want to implement going up and down with the arrow keys for each module. So I'm going to copy this statement here, paste it into the expanded for key down. We're going to change the current tab to module index. We're going to copy this list here, paste it in the event key implementation, and then go down to where it's calling for the length. And we want to change that to modules.size. We're going to copy this version and paste it there so that they work accordingly to the direction. And then we also want to copy the index and replace these three occurrences and copy the size. So now if we save that and we press the down arrow, we're going through the different modules in each tab. We're almost done. So now we want to say if the key is right. If it's expanded already, we want to do something else than if it wasn't expanded before. So if it's already expanded, we want to toggle the module. It's pretty simple. We can take this module list here and we can say modules get and then the module index dot toggle. It's that simple. So if we select player, select NoFall, and then use the right arrow, it toggles it. And I just turn off the TabGUI. We can prevent you from disabling the TabGUI with the TabGUI by doing this. We're going to create a new module object called module that uses the module from the list, but it simplifies what we're about to do next. So you can replace the occurrence of that with just the module local variable. But above it, we're going to say if module dot name equals TabGUI, or more so if it does not equal, so putting an exclamation point in front and indenting, it will not toggle the TabGUI anymore. So if I go to render, TabGUI, press the right arrow key, nothing happens. Whereas if I do it with other modules, it does. We also need to say if the module list size is 0, we don't want to process anything. We don't want to get it from the array. We just want to say if expanded and modules size does not equal 0, then we can do that. So if we go to combat and we press the right arrow, it won't crash the client, whereas it would have crashed it before, but everything else still works. So we've currently been storing the module index in the TabGUI itself and not in each individual category. So you notice if I go to the bottom of this category where TabGUI is and then I go to player and I open it up, it's hovering over a non-existent module, and if I were to write it, it would crash the client. So we want to store the indexes in each category. So I'm going to copy this variable. I'm going to go to the category declaration, and then right after name, I want to say public int, and then paste that in there. Now to implement it, I'm going to erase it from the TabGUI, and in order to implement this properly, we need to create a selected category variable. So I'm going to create right after modules, actually above modules, that'd make it even more optimized. Category equals this, and then I can plug that there, and I can also plug it in front of this, in front of that, and the same, I can just copy this whole statement and replace the modules list in the event key as well, and then I can paste that in front, and the other places as well. Now if I start up the client, each category will have its own indexing system and there will not be non-existent modules. So as you can see, if I go to the bottom of movement and then I go to player, we're still on NoFall. And same with other categories. If I go to the top of sprint and then I go to render, we're still on TabGUI. This concludes part 4 of the Minecraft 1.8 hacked client coding tutorial, and I hope to see you in the next video.